Hey folks, and this is lab number 10. In today's lab, we are going to look at recursion again. And for today's lab, what I'm going to do is I'm going to do a quick example where we sum up all of the numbers in an array. So we're going to start off here in, I'm going to do this one in Replit just to make life easier. And so what I'm going to do is I'm going to define an array, which is going to be done down here. So I'm going to say an array of integers, int my array equals new or int, and we're going to do size. Well, actually, I tell you what, we're just going to define the array here with numbers in it. So I'm going to do 2, 3, 6, 8, 10, 20, 30, and 50. All right, and so that's how you define an array and go ahead and pre-populate it. So that array is going to have 7 cells in it. That's going to be in cell 0, that's going to be in cell 1, and so on and so forth. All right, so we're going to make a call to a method, and we're going to use something called SumArray. So we're going to say SumArray, we're going to pass it my array, and hopefully that's going to return back to me an answer of some kind. So let's go ahead and define that method. So up here we're going to say public static int SumArray, and it's going to take in an array of integers called the array. All right, now this is going to be recursive. So what we're going to have to do is we're going to have to figure out how to sum up all the numbers in the array. So the first question that we have to answer, as always, is what is the base condition? What circumstance under which will we have nothing to calculate that we can just directly answer the question? And I guess that would be if we were given an array that has nothing in it or an array that only has one cell in it. So let's do the array that has nothing in it. So the problem that we have here is we're eventually going to have to make a recursive call. And that recursive call is going to tell us where we are in the array that we have already summed. So specifically, we have an array here. And what we're thinking about is, and I'm just going to start up a little screen here that I can draw on. Okay, so let's hit plus. And hopefully we have this. All right, so let's draw an example array here. And what I'm going to do is I'm going to just fill in some values into that array. So it looked like we had, let's take a look here. What did we have? We had 2, 3, 6. And then we had 8, 20, 30, and 50. I have planned poorly as usual. So we're going to drag that out to make it a little bit bigger. Okay, so that's basically what our array looks like. So specifically, this is cell number 0 of the array. And over here, we have cell number 1 and so on and so forth, all the way down until we get to the far end of the array. So let's see. So we've got 2, we've got 3, and again, there are 7 cells here, but 0, 1, 2, 3, 4, I cannot count. There should be a 5. Goodness. All right, and that one should be a 6. There are 7 cells, but they're going to be 0 through 6. Okay, so basically what I'm saying is, if you give me an array where there's nothing in it, so if you had given me the array with no entries in it, then the sum would be the sum is 0. And I think that's pretty obvious. In all other cases, then what you're going to give me is sum is one of the cells plus the rest, right? And I'm specifically thinking about it like this because that's how you think about recursion. I need one thing and then the rest. So I could do this either way. I could start at the beginning of the array and say that the sum is going to be what's here in this first cell plus all of these, or I could say it's the one that's in the end of the array plus all of these. And it doesn't really matter which way I go. The thing that matters is that eventually the array is getting smaller and smaller and smaller, and at some point I will reach an array that has nothing in it. So how am I going to actually do that? Well, there are methods for finding a subset of an array. So as I said, there are ways that you can make a copy of an array. Very specifically, the one that I'm going to look at is called copy array, which is a part of system. And so I'm just going to demo how that works real quick. We'll come back to the recursive part of it. So effectively, I want to make an array that only has those values in it. So what I'm going to do is I'm going to make a second array, which I'm going to call new array. So int new array equals new int, and this is going to be of size 6 because it's one less than the size of the existing array. And then I'm going to say system.copyArray, and it's going to take a bunch of parameters. The first parameter is the old array, which is my array. Second parameter is where I want to start copying from, and I want to start copying from cell 1, because remember this is cell 0. So I'm starting at cell 1. And then the next is the new array that I want it to copy it into. And then it takes a parameter which says where do you want to start in the new array, which is cell 0, and how many cells do you want to copy, which is going to be 6 cells. All right, and then just to prove that that actually did what it was supposed to do, what I'm going to do is I'm going to say for int x in new array, I'm going to system.out.println that new array. And so what I should see on the screen when I run this is 3, 6, 8, 20, 30, and 50. And then probably hello world. So let's see. System copy array. It's array copy. I wrote it backwards. Sorry. Array copy. There we go. And so again, hopefully we're getting these values right here. Okay, 3, 6, 8, 20, 30, and 50. Okay, so that's a way of creating a smaller array. And so that's what we're going to need in order to pass a smaller array to subsequent versions of the method. So, all right, let's take that in and see where we are. So it sounds like if the array dot size is equal to 0, then return 0. That's the very basic system, right? If you're given an array and the size of the array is 0, then return 0. In all other cases, then we're going to have to calculate this subarray, the smaller array. So I'm basically going to copy some of this up here, and we're going to actually cut it and then paste it in here. And then we're going to fix all the crazy formatting. Okay, so there we go. And I don't need to print it out, I just need to calculate it. All right, so this is going to change a little bit. So this 6 is not always going to be 6. It's going to be the array dot size minus 1, because whatever it was previously, we're going to have to subtract 1 from it. And likewise, this is always going to start at 1, and this is going to be the array dot size minus 1, because that's how many we're going to be copying over, which is how many items there are in there. All right, so finally, we're going to make a recursive call here. And so we're going to call some array, and we're going to pass it this new array. All right, now to that, we're going to add the value in cell 0, which is the array at 0. And that's what we're going to ultimately return. All right, I'm going to take out this return 1 that's down here because it's meaningless. That would never happen. And let's take a look at this and see if we get what we would expect. So in theory, the first time through, it's going to produce this little array, and then it is going to tell us the sum of 2 plus this. And I always forget this. What is the calculation? Is it array length? It is array.length. All right, it's not size, it's length, sorry. I always get that one wrong. And there we go. Was that the only problem, or was there anything else? I really didn't read the screen. Array copy my array. It's actually called the array. And the array, the array, the array. Yep, that looks reasonable now. So let's see if we get the right answer. All right, so while you're waiting for the compile, you should always do a quick, I missed one case. You should always do a quick smell check of what you think the answer should be. So very quickly adding these, that's 80, that's 108, 114, 117, 119 is I think what we should be getting back as the answer here. And what we actually got was hello world, because I never actually printed out the answer. It even underlined it to tell me you created something and then never did anything with it. All right, so with any bit of luck, we get 119. It's a good sign that we got to the hello world because it means it wasn't infinite recursion. And it looks like we got 119. All right, so to review, how did I get here? I'm taking in an array. it has some numbers in it. We don't really know what the numbers are going to be, but we know that there's going to be some set of numbers. If we're passed in an array that is empty, then the answer is 0, because that makes sense. If you gave me nothing to sum, then the answer is 0. That's a base condition. In every other circumstance, what I did was I took the first number, which is that 2 in this case. That's right here, the array at position 0, and I added it to a recursive call passing all the other numbers. And that's what this did. It just created a smaller version of the array with everything except that first number in it. And then that recursive call starts, and when it starts, it received this part of the array, the part that's highlighted here, and it did the same thing. It said, is the length of this 0? It's not. So then it took this number and added it to the sum of that, which made another recursive call. Is the length of that 0? No, it's not. So it took this number and added it to the sum of that, and so on and so on and so forth until it came to here. It was passed an array with one cell. It said, is the length 0? It's not. So it made a recursive call again with the smaller array, which is an empty array. That added up to 0. And so in the previous call, it said 50 plus the 0, which answer was 50. When that got returned, it got returned to the one that was trying to sum these two numbers. So it answered 50 plus 30, which is 80. That gets returned to the one that was trying to add 20 to that. So it was 20 plus 80, which is 100. 8 plus 100 is 108. 6 plus 108 is 114. 3 plus 114 is 117. And 2 plus 117 is 119. And we get back our final answer. The order in which you do this, this is your recursive call. Let's check the 3 things that I told you to always check for. The first thing is, are you creating a base condition? Yes. Yes, I am. There's the base condition right there. Gave me an array that has nothing in it. That's your answer. The second thing is, did you make a recursive call? Yes, I did. There's my recursive call. And are you passing it something that is moving you closer to the base condition? Yes, what I'm passing is new array, which is smaller than the array that I was originally given, specifically one cell smaller. So I'm getting closer. And then the last thing is, did you do math or whatever it is you're trying to do to actually calculate your recursive answer? And the answer is yes, there it is. So that's another recursive example. I hope that helps you guys out with this week's lab, and I will see you guys next week.